Okay, so let's start non-destructive testing. There are various kinds of non-destructive testing, but as far as our syllabus is concerned, there are three kinds of tests which are included in our syllabus: eddy current test, sonic and ultrasonic testing. Okay, and usually it is called as ultrasonic testing, and X-ray radiography testing. Okay, and actually only principle and applications of these three tests are included in our syllabus. Okay, so we'll go through these tests. Okay, before that, we need to understand what is the necessity of non-destructive testing. See, in many applications, okay, you are not allowed to destruct the component. In some cases, you may face that value, or you can say cost of the that particular component is very high. For example, suppose if a particular component, say for example, a particular car, okay, which are expensive cars, okay, of any expensive car, a particular component is say of price say around 50,000 or say 1 lakh rupees. Okay, you cannot destruct that 1 lakh rupees component for just for testing. Okay, so what you need to do is you need to use such a test which will not destruct the component, which will not make any damage to the component, so that the component will remain as it is even after test. Just you will be able to test whether there is any defect, whether there is any flaw in that particular company. Okay, so this is first, you can say, advantage of non-destructive testing. Second thing is, uh, whatever defects are there inside the material, okay, that can be detected by non-destructive testing. Okay,
Hello.
internal defects can be
Yep.
uh, detected by
घेतलंय
non-destructive.
मी तोच चहा द्यायचा पासवर्ड आहे.
Internal defects can be detected by non-destructive testing. Okay, next thing is, okay, another important thing is, it can test the components which are in use. This is very very important, because some components of certain applications are like that, where you cannot remove that component from that application. Those components are in use, and at the point of that application, at the site of that application, you have to check whether there is any problem in that component or not. Okay, so that can be checked by non-destructive testing. Okay, so for example, say if you have a bridge which is made up of say metal. Okay, if you want to check whether there is any small cracks or no in that particular bridge, or in the main beam, or whatever is that main structure of that bridge. Okay, you cannot remove that beam, or you cannot remove that main structure from that particular bridge, and you cannot take that to your lab for testing. Okay, what you have to do, you have to test that bridge, you have to test that structure at the point of that application only. Okay, so this is the main advantage of non-destructive testing. Okay, so we'll discuss one by one all these tests. First is eddy current test. Okay, obviously eddy current, when its name is eddy current test, there must be some major role of current. Okay, so that we'll see how current plays important role in this particular test. Okay, uh, usually eddy current tests are used for non-ferrous metals, and one more criteria that should be, the material should be conductive material. Okay, otherwise there is no use of current. Okay, so we are using current, that means the material should be conductive, it is obvious. Okay, uh, during this process, that means during this stage, AC current is passed through the coils. So some coils are designed for this particular application, and in those coils, AC current is passed. Okay, and this and the test, or the specimen on which you are going to carry out the test, that specimen is passed through that coil. Okay, now while passing through that coil, or while when you keep that specimen inside those coil, what happens usually, secondary currents, okay, which are usually called as eddy currents, starts to flow through that specimen. Okay, now as eddy currents induces in the process, okay, definitely magnetic field starts flowing in the specimen. Okay, so what you need to do is, to this whole system, an oscilloscope is attached. Okay, and that oscilloscope will measure the magnetic field. Okay, will check the magnetic field, and if there is any flaw, if there is any change in the magnetic field, that will be detected by that oscilloscope. Okay, so on the oscilloscope you will be able to see whether there is any defect, whether there is any flow. If there is any flaw in the magnetic field, if there is any change in the magnetic field, you will be able to understand, okay, there is a defect in this particular component. That will be your final conclusion after this eddy current testing. So this is a typical, you can say, structure or line diagram for a eddy current test. So where you can see the coils are there, okay, and this blue color shows the magnetic field produced, okay, and this gray color is nothing but your specimen. Okay, and these are the green colors shown are the eddy currents, which are induced due to AC current. Okay, and one more diagram is there, this one. Okay, so this same diagram, this one is also okay. Over here you can see the coils, okay, and at the center you can see the specimen. Okay, over here, okay, let me take spotlight. Okay, so at center you can see the component, okay, over here, and to these coils some AC current is provided, okay, through this supply. Okay, and oscilloscope is, you can see, connected at the top, so where you can see what kind of changes are there. Okay, so some crack type of structure or some any kind of, say, a blowholes type of structure is observed in this oscilloscope, on the screen of that oscilloscope. Okay, so this is eddy current testing. Next procedure or next test is ultrasonic testing. Okay, so obviously there will be a major role of ultrasonic sound waves. Okay, so in case of ultrasonic testing, ultrasonic sound waves are usually bounced on the specimen. That means on the specimen surface. Okay, when those ultrasonic sounds are bounced on that surface, okay, those ultrasonic sound waves comes back to the receiver. Okay, now during this process, okay, that means bouncing off and coming back to the receiver. Okay, during this process, if there is any change in the time taken by that wave for traveling, what I am saying, if there is a change in the time taken by that wave, okay, for traveling, okay, that means if there is any change, you can conclude that there is a certain flaw, there is a certain defect in the component. Okay, I will show you with the help of this, with the help of one diagram, and you will easily understand. Okay, this one. So here is the ultrasonic sound wave receiver, you can say, or this one, on the top of this specimen, and this is your specimen, this gray color is. Okay, so this has started, say, from this left point of the specimen, so it will travel from this point to this point. Okay, so at initial points there is no any kind of defect, so sound waves will travel from this point to this point, and it will come back to receiver again. Okay, so it will travel from this top surface to the bottom surface, and from this it will bounce back to the receiver. So time taken by the waves will remain same until it comes to this crack. As there is a crack, that means there is a gap. So as there is a gap, that means sound waves will not go to the bottom surface, those sound waves will bounce back from this crack itself. Okay, now if you check, time taken in this particular region, time taken by the waves in this particular region will be obviously more than this one. Okay, so this time change you can find out. Once time change is find out, once time change is observed in the oscilloscope, that means there is a certain crack, there is a certain gap. Okay, or there may be some blowholes, those kind of defect, there may be some you can say tears in the component, there may be some, you can say, internal stresses in the component, whatever it is. Okay, so on the basis of that you can conclude that there is a defect in the component, but it will not tell you whether there is exactly any crack or anything, but you can uh, qualitatively say that the component is defective, component is not okay, component is not perfect, you can say, after observing such a, you can say, such a things in the component. Okay, so this is called as ultrasonic testing. Okay, so here also one more diagram is shown over here. So this is your ultrasonic sound wave probe, you can say, or receiver, you can say, and this is your test piece. So on the test piece, this probe is moved. Okay, so on the screen of your computer, or you can say oscilloscope, you will find that time taken by the waves, okay, to bounce back. Okay, so here in detail it is shown over here. So if there is any fault, if there is any crack, that your sound wave will bounce back in rapid time. So where you can see the oscilloscope, in the first two waves it is showing more time required, in the second two it is showing less time. That means there is a fault. Any change in the time taken by the waves to travel, there is a fault, that means. Okay, next test is X-ray test, or you can say radiography testing. Okay, so all of you know how X-ray usually works. Okay, X-rays are released by hitting the cathode. Okay, obviously that is the major source. Next is they are then, that means X-rays are then accelerated by DC current and directed onto the specimen. Okay, by the tungsten anode. The X-rays then pass through the test piece onto the X-ray film. So where you will get the final image. Okay, where you will get the where it will be visible. Okay, you will see over here in this particular diagram. One more diagram I will show you. Okay, this is better diagram. Okay, this one. Okay, so this is your source. Okay, and these are the rays. You can see X-ray. So these rays will strike on this component, okay, over here, and whatever there is defect, now as this dark black color is the defect, okay, or maybe a crack, you can say, in the component, that is visible on the developed film. You can see over here in the bottom diagram. Okay, this one. And one more thing that you can observe during this X-ray testing, if the component is thick, if the component is thick, its image is you can say light in color. If the component is thin, its image is dark. Okay, you can see over here. Okay, now this depends on the this darkness of the film usually depends on the amount of radiation reaching the film, okay, through the object. Now as you can see, the light color means less exposure to the rays. Okay, less exposure by the specimen to the rays, and as the dark color shows the more exposure to the rays. Okay, so this will give you a clear idea. So after carrying out this X-ray testing, what you can do is you can take out this film, okay, and you can just observe this film in order to find out is there any defect present in the component or not. Okay, so this is as simple as that. This is also used in medical field also. All of you know that. Okay, X-rays. Okay. It is very simple. Okay, here we can see some components and their radiographic image. Okay, X-ray images. Okay. Okay, yeah, sure. You can see this is one component, maybe a casting or sheet metal. It is difficult to observe. Okay, and that X-ray image of this one is over here. Okay, bottom one. This one X-ray image is for this, and one more component is there X-ray. Now, one major advantage of this radiography, X-ray radiography, is it can test any material. Okay, it is not compulsory that it should be metal. It is not compulsory that it should be conductive. It is not compulsory that it should be non-conductive. It can literally test any metal, any material rather, metal, not metal, any material can test. Okay, metals, non-metals, everything. Okay. Now, apart from these three tests which are included in the syllabus, two more tests are there. Okay, one is a dye penetrant test. Okay, and second one is a magnetic particle test. We will discuss those also, because I doubt, though only three tests are included in the syllabus, I feel maybe any one of these two tests may be asked in your exam. So we'll just discuss, okay, these two tests. So next test is the penetrant test, which is usually referred as the dye penetrant test. Okay. In earlier days, okay, a mixture of chalk and oil was used to conduct the dye penetrant test. But nowadays, a fluorescent colored dyes are used to check the defects. Okay, now defects in the sense, in case of dye penetrant test, if you check, defects in the sense surface flaw. That means on a surface, okay, on a surface, if there is any crack, if you want to check, see, cracks I can check by naked eyes also, but very small cracks, okay, very small cracks, I cannot check by my naked eyes. So in that case I have to conduct any test in order to get that clear. Okay, so for that dye penetrant test is used to check the surface flow. From this diagram itself you will understand what is a dye penetrant test. Okay, so say for example such a crack is there on the in the first diagram, you can see such a crack is there. Okay, now this crack is present in the component, but we don't know that this crack is present in the component. Okay, what we'll do in the first case, on this surface of the component, okay, the fluorescent penetrant, or you can say the dye, is sprayed all over this surface. So obviously what will happen is that dye is in liquid stage. So what will happen, that dye will go inside the crack if there is any crack in the surface. Okay, now you can use some spray or some nozzle to make sure that all the dye, if there is any crack, the dye will insert, or dye will go inside the crack. Okay, after this what you can do is you just wipe out the surface, wipe out the dye from this surface, but whatever dye which has gone inside the crack, that will remain there only. Okay, after that what you can do is you can take that component, okay, or you can expose this component to ultraviolet light source or ultraviolet light rays. Okay, so those ultraviolet light will show, due to the fluorescent dye, it will show clearly that there is a crack. That is enough. So once you observe such a kind of structure, that means you can easily show, you can be sure that there is a crack in the surface. Okay, so this is about this is for surface test only. Okay, you cannot check any internal crack by using dye penetrant test. This is the biggest disadvantage, because in earlier test, in case of ultrasonic testing, or in case of even your x-ray testing, you can check internal cracks also. That means cracks in the interior of the component. In the case of dye penetrant test, you cannot check the internal cracks. Okay, cracks present in the interior, you can check only surface crack or surface flaws. Okay, by using dye penetrant test. Next test, or the last test we can say, is the magnetic particle testing. It is very easy, it is very easy. It is usually used on ferrous metal. Okay, what is done in this case is the component to be tested is first magnetized. Okay, now obviously that will carry some magnetic effect. Okay, after that magnetic particles, which are usually dry, okay, which are usually dry, are sprinkled on that specimen, magnetized specimen. Okay, after sprinkling that, if the component is perfect, if there is any defect, all the magnetic particle should lie in a same pattern all over the component. But if there is any defect, the magnetic particles will show certain changes in the pattern. So by naked eyes you have to just check if there is any change in the pattern of the spreading of the magnetic particles. Okay, if there is any change, that means there is some defect in the component. Okay, that you can easily understand. Okay, or in this diagram it is shown over here. Okay, if there is a defect, this kind of, okay, this magnetic particles will show different pattern at this particular point. Or if even if you can see over here, if there is any crack, magnetic particles on the top of the surface will show some difference in the pattern. Okay, so by identifying that change in the pattern, you will easily understand if there is any defect present in the component. Okay, now what are the common applications of non-destructive testing? I already told you why non-destructive testing is used, what is the necessity of non-destructive testing is used. Still we'll discuss few more things. Some common applications are inspection of raw products. Okay, see, some processes are there which are usually referred as a forming processes. Those forming processes use raw material which is called as ingot or billets. Okay, so those billets or ingots are taken to the forming processes. Okay, so before taking those billets or ingots, or you can say raw materials, for final process, you can check by using non-destructive testing if there is any defect present in those uh, what you can say as the raw products. Okay, if there is any defect, you can reject that component from your lot. Okay, this is one thing. Second thing is inspection following secondary processing. That means something like after casting or after making some raw products, when you are going for say machining. Okay, maybe if you are going to make certain shape on a lathe machine, okay, simplest machine I will consider. If you are going to take, or if you are going to make any shape on a lathe machine, in that case, before going for operation on lathe machine, you can check the component for any defect. If there is any defect present in the component, what you can do is you can reject that component. Okay, and you can take the new component for your processing. Okay, this is one thing. Second thing is maybe in welding processes. Okay, actually non-destructive tests are widely used in welding processes. In case of welding processes, after welding, okay, after welding, whether the weld has or whether the components have properly joined or not, that you can check by applying non-destructive testing on the welded parts. Okay, so whatever the welded section is there, on that welded section you can just carry out any non-destructive testing, maybe x-ray testing or maybe dye penetrant testing, or maybe any test. Okay, out of these five non-destructive testing, you can carry out non-destructive test on that welded part, and you will easily understand if there is any crack, if there is any defect in the welded part or not. Okay, so these kind of secondary processing, in that also you can use the non-destructive testing. Next thing is in case of say heat treatments. Okay, after making a component, okay, to change the properties, usually heat treatments are done on the component. So after manufacturing a component, what you can do is you can check any if there is any defect in the component by just applying non-destructive test on that component. Okay, if there is any defect, don't take that component for heat treatment. If there is any if there is no defect in the component, you take that directly for the heat treatment. Okay, these are now common applications. One more thing is, if there is any in-service inspection, in-service damage inspection, okay, that also you can check by non-destructive testing. I have given you this last image. Okay, these images are relative. The first one is of forming process, the first image is. Second image is of heat treatment. Okay, third image is of coating. Okay, making some coatings on the components. This fourth image is of machining on a vertical machining center. Fifth image is of welding process. Okay, and this last image is ropes. Okay, these wire ropes. Okay, suppose in case if you have any doubt that there may be some problem, or there may be some tension, there may be some defect in the wires, you cannot just tell all your customers that get down from this car and we need to check the rope if there is any defect. Okay, next time no customer will come to you for this to sit in the car. Okay, for this rope. So what you can do is you can check these ropes. Okay, when it is in application only. Okay, if there is any damage in the rope, or if, even if there is any not any damage, but still if you feel I should check just for precaution, you can check that by non-destructive test. Okay, what we'll do is now I have few videos of this test. Okay, so we'll try to see that because we have 7 minutes almost. Actually very long videos are also there. I'll check if they dye penetrant test is there, very short video. 8 minutes. I will send all these videos to you. Magnetic particle inspection. Okay, dye penetrant test will see. Is it audible?
Not sure.
Okay, wait. Is it audible now?
Yes, sir.
Penetrant examination is an important method of non-destructive testing of materials. This is the basic principle. Often the surface of a workpiece is covered with rust or paint, which masks the material defects, as shown in the sectional view. Therefore, the first step is always the pre-cleaning of the test piece surface.
Okay, so before going for test, just clean the surface of the test, surface of the specimen.
Must be done very thoroughly so that any defects present, here it is a crack, are open to the surface. In the second step, the penetrant is applied to the test piece.
This is your penetrant, which is called as a fluorescent dye color. Okay.
Usually a red-colored low-viscosity oil. Due to the penetrant's high surface wetting capability, it penetrates into the defects and cracks.
Okay, so the penetrant will go inside the defects or go inside the crack surface. Okay, on surface only.
After several minutes of dwell time, the third step is to rinse the part's surface cautiously with water. The water removes the penetrant completely from the surface but leaves it in the crack. Now, the fourth step. After drying the test piece, a developer is applied onto the surface. The developer is a fine-grained white powder suspended in a liquid. It forms an even coating on the surface. After drying, it draws penetrant from the crack out onto the surface. The location of the crack is indicated clearly on the surface. And this is how it is carried out in practice. We wish to inspect two samples, a segment of a worm gear shaft and a broken bicycle crank arm. Both test pieces have already been cleaned. First in line is the worm gear shaft. The material tester applies the penetrant. After a dwell time of about 10 minutes, she removes the excess penetrant from the surface by rinsing the test piece gently with water. She takes care not to rinse for an unnecessary long time because the penetrant is supposed to stay in the defects. Now she dries the surface of the sample with a cloth to absorb the excess water. As the final step, she applies the developer and lets it dry. That's it. Several cracks are indicated on the surface in deep red color.
Okay, so these are the cracks. Okay, these dark red color shown are the cracks present in the component. Okay.
Next, the broken bicycle crank arm has to undergo the dye penetration test. Spraying with penetrant, allowing to soak, rinsing, drying, and applying developer. Clearly, additional cracks are indicated on the fragments. Finally, the pros and cons at a glance. Advantages of this test method are almost.
Okay, all of you understood what is the dye penetrant test?
Yes, sir.
Okay. Actually, I have a video of eddy current test and ultrasonic also, but it is a very lengthy video, 8 minutes. This is of 17 minutes almost. Okay, how many? Okay, okay, time is almost over. 1 minute is there. Okay, someone take the screenshot of the attendance. I will send all these videos on on that WhatsApp group. Okay, EMM group. Okay. Someone take the screenshot of the attendance. Okay, if you have any doubt, you can ask me because we have more than 1 minute now.
Sir, Eddy current, sir,
You are not clearly audible. पुन्हा विचार.
Sir, Eddy current is the answer. Very short, but
Not audible. Just send your question on that EMM group. Okay, send your question on that EMM group. I will answer that. Okay, so we'll stop here. We'll meet in next lecture. Meanwhile, I will arrange 1 or 2 practical sessions, because we have already conducted 1 practical. 1 or 2 more practicals we will conduct, because we need to carry out fatigue and grip test, as well as those hardness and toughness tests also. Okay, so we'll carry out those tests meanwhile. Okay, see you. I will end over here.